So hello everyone, welcome. So I think my voice is audible, right? Voice, the video is clear. I'll just check whether everything is correct. I'll just check whether. Okay, so we'll start lecture number 4. So in the previous 3 lectures, we have seen limits, continuity, differentiability, and roles and Lagrange's theorem, right? So we have completed 5 topics: limits, continuity, differentiability, roles theorem, and Lagrange's theorem, right? And then we did some very good problems. So in this class, we're going to start asymptotes and curve tracing. So there are 2 topics we're going to discuss today. One is we're going to find asymptotes, and then we're going to find, and then we're going to curve trace, right? We're going to trace the curve, and then we're going to draw the diagram for it. So first, we'll get on to the first topic, which is asymptotes. Very easy, right? Very easy. So we'll start with asymptotes, right? So everyone would have come across the definition of asymptote, right? A line is, see, whenever I'm talking about asymptote, you need 2 things. One is you need a line, and then you need a curve, right? You need line, and then you need a curve. So a line is said to be an asymptote, right? We have 2 things. We have a line, and then we have a curve, and then we have a curve. A line is said to be an asymptote to the curve if that curve and the line are becoming closer and closer and closer and closer and closer, but they will never touch, right? But they will never touch. So you can see this curve will be approaching very, 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 very closer to this line, but they will never touch, right? If this happens, then we say this line, this line is an asymptote for the curve, right? So what is asymptote? Again, I'll repeat. We have a line. A line is said to be an asymptote to the curve if a curve approaches this will become very, very, very closer, but it will never touch, right? Maybe they will say that they will touch at infinity, but it will not happen, right? So a curve and the line, this is a curve, this is a line, and this is a curve. So this line and the curve will become very, very, very closer, but they will never touch. If that happens, then we say this line is an asymptote to this curve. An asymptote An asymptote is a line that a curve continually approaches but never fully touches or crosses. As the curve extends infinitely, the distance between the line and the curve shrinks to zero, right? After some stage, it will become very, 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 very closer to zero, right? It will become very, very closer to zero. So if this happens, then we say line is an asymptote to the curve. Now, in this topic, what they will give is they will give a function of 2 variable x and y will be there in the function. We need to find all asymptotes to the curve. We need to find all asymptotes to the curve. We need to find how many asymptotes that curve has, how many asymptotes that curve has, and then we need to find the equation of this asymptote also. This is a line, right? So we need to find the equation of this line. So we know equation of line is what? Y is equal to mx plus c. So we need to find all line such that that line is an asymptote to the curve. Such that that line is an asymptote to the curve, right? Okay. Now the asymptotes are classified into 3 types, right? The asymptotes are classified into 3 types. One is vertical asymptote. One is vertical asymptote. Right. If the line is vertical, it means that is a vertical asymptote. That's it. The very first example, I have drawn one line and I have said that this line is an asymptote to the curve. This line is not vertical line. It has some slope, positive slope. Suppose if this line is a vertical line, then that line is an vertical asymptote to the curve, right? So it is called as vertical asymptote. So the first asymptote classification is vertical asymptote, right? Vertical asymptote. And the second one is horizontal asymptote. Horizontal asymptote. And the third one is oblique asymptote, right? Oblique asymptote. Now, how the vertical asymptote will be? For example, I will just draw a line, right? This is your asymptote, and you can see this asymptote is a vertical line, right? This asymptote is a vertical line. Then the curve will be like this, right? It will become very, very closer, but it will never touch. This is the vertical asymptote. Example of vertical asymptote. Horizontal asymptote, let us say this is for horizontal asymptote. In that case, the curve will be like this, right? This is an horizontal asymptote. We're going to find all equations also, right? Equation of this line, all. Oblique means if it is not vertical or horizontal, it has some, let us say this has some, this is some line y is equal to mx plus c, and this is an asymptote, right? So you can see that asymptotes are classified into three types. One is horizontal asymptote, other is vertical asymptote, and then oblique asymptote. Now, how to find all these asymptote, right? How to find vertical asymptote, how to find horizontal asymptote, how to find oblique asymptote, right? How to find all oblique asymptote. Now, to find vertical asymptote, they will give a function of x comma y, right? So, given a function of x comma y, they will give a curve that will be a function of x comma y. So given a curve f of x comma y, if you want to find all vertical asymptotes, see vertical asymptote means asymptotes parallel to y-axis, right? Asymptote parallel to y-axis. Now to find all asymptotes, parallel to y-axis, that is you are finding vertical asymptotes, right? To find all vertical asymptote, you equate the highest power of y to be equal to 0. When we do problem, it will be very easy for you, right? Equate the highest power of y to be equal to 0 in the given function x comma y. Now to find all horizontal asymptotes, so given a function x comma y, to find all asymptote, parallel to x-axis, equate, that is you are finding all alternate asymptotes, right? Equate the highest power of x to be equal to 0. So it is very easy to find vertical asymptotes and horizontal asymptotes. Now to find oblique asymptote, I will tell you one procedure. It is long, but it is very easy. Now procedure to find all oblique asymptote, right? Procedure to find all oblique asymptote. See, I will write the procedure. When I do problem, it will be very easy for you. Right? When I do problem, it will be very easy for you to understand, right? So given a function of x comma y, let us say it has degree n, right? Say it has degree n, right? Say it has degree n. For example, f of x comma y is equal to x square plus xy plus x cube. This is a degree 3, right? This degree is 2. This degree is also 2. Whenever a function of two variable, you need to add the powers of all the variable inside this. So this is also degree 2. This is a degree 3. Now this is a degree 3 equation. Right? This is a degree 3 equation. Now let us say it has a degree n, right? When I do problem, it will be very easy for you to understand. Let us say we have given a function x comma y of degree n. Now what you need to form is you need to collect all nth degree terms. You collect all n minus 1th degree term, and then you collect all n minus 2 degree term. You keep on until you collect all the constant term, right? You collect all the constant term. See, maximum your question will be, highest degree will be 3. So in that case, you collect all degree 3 term, you write degree 3 terms, you write degree 2 terms, you write degree 1 term, and then you write degree, and then you write constant term. 99.5% your question will be maximum, it will be of degree 3 only. So that means phi3 of x comma y, phi2 of x comma y, phi1 of x comma y, and then phi naught of x comma y. So you just write the functions here, right? You just write the functions here. When you do problem, it will be very easy for you to understand, right? So what I am doing is you write nth degree term, you write n minus 1th degree term, n minus 2 degree term, and then you write the constant term. Now here, what you have to do is you have to put x is equal to 1, y is equal to m, right? You have to put x is equal to 1, y is equal to m. Then this will be reduces to Pn of m, and this is reduces to Pn minus 1 of m. Because if you in this term, if you put x equal to 1 and y is equal to m, it will be a function of m only, right? This Pn of function of x comma y will turn out to be a function of m. So P1 1 minus 1 of m, Pn minus 2 of m, and so on up to phi naught of constant term, right? Phi naught of m. Now to find we are finding all procedure to find all obliquely asymptote. So let all asymptotes be y is equal to mx plus c, right? We need to find all oblique asymptote y is equal to mx plus c. That means we need to find the value of m and then we need to find the value of c, right? We need to find the value of m and then we need to find the value of c. Now to find m, equate Pn of m to be equal to 0. So we have highest degree term here, right? We have to equate that to 0. It will be an equation in m, solve for m to get the roots, right? Solve for m. Equate Pn of m and solve for m. Now let us say you are getting 1m or 2m or 3m's or 4m's. Maximum this Pn of m will be a cubic equation or quadratic. If it is cubic means you will be getting 3 roots, right? So all 3 can be distinct or 1 can be distinct, 2 can be equal also if it is real root, right? If it is real root. Now you have to solve for m, and for each m you need to find corresponding c value, right? For each m you need to find the corresponding c value. Now to find c for corresponding m. Now to find c for corresponding m. So let us say you will be getting different. Let us say you are getting 3 m's, right? For each m you need to find c. For each m you need to find c. If your m is distinct, if m is distinct, right? If your m is distinct, then that c is given by minus Pn minus n of m divided by Pn dash of m, right? If m is equal roots, if m is equal roots, if m is equal, that means let us say you are getting cubic equation. Let us say the roots are 1, 2, 2. Now for this m, the corresponding c can be found using this case because there is only 1, 1. And for this 2 and 2, they are equal roots, right? And for this m, the corresponding c should be found using this formula here. If m is equal, right? If m is equal, then you have to find c using c square by 2 factorial p n dash pn double dash of m plus c by 1 factorial pn dash of m plus pn minus 1 of m equal to 0. No, no, pn minus 1, pn minus pn minus p dash of n minus 1 of m, pn minus 2 of m is equal to 0, right? So that's it. So when we do problem, it is very easy, right? It is very easy. When we do problem, we will come to know, right? So we'll directly get into the problems, right? I have given you all the procedure to find vertical asymptotes, to find horizontal asymptotes, and then to find oblique asymptote, right? Okay, so we will move on to problem number 1. Find all asymptotes of the curve 2x plus 3 into y equal to x minus 1 whole square. So we will find all asymptotes, right? So first what we'll do is we have a function x comma y. So f of x comma y is given as 2x plus 3y minus x minus 1 whole square. This is 2x plus 3y minus x square minus 2x plus 1. So we have 2x plus 3y minus x square plus 2x minus 1, right? So first what we will do is we will find all vertical asymptotes. So vertical asymptotes are asymptotes parallel to y-axis, and for that you need to equate highest power of y to 0, right? So first what we will do is we will find all vertical asymptotes. So for vertical asymptotes, equate the highest power of y to be equal to 0. See here there is only one, y power 1 is the highest power of y, right? We have only y here, there is no y square, y cube and so on. So highest power of y is 1. So equate the highest power of y to 0. Equate the, or I can say equate the highest power of y to 0. That means 2x plus 3 is equal to 0. That means 2x equal to minus 3. So x is equal to minus 3 by 2 is your first vertical asymptote this curve has, right? Equate the highest power of y to 0. So highest power of y is 1. Or can I say equate the coefficient of highest power of y to be equal to 0, right? Or I can also say like that. So equate highest power of y to be equal to 0. So we will get that is coefficient, right? So x is equal to minus 3 by 2 is your first vertical asymptote. So at x is equal to minus 3 by 2. See, vertical asymptote is always equation of the form x is equal to a, right? Vertical line equation is x is equal to a, and a is the point it is passing through. And horizontal asymptote will be of the form y is equal to b is a point that it is passing through this point, right? And this is y is equal to mx plus c. Now x is equal to minus 3 by 2 is your first vertical asymptote this curve is. Now we will find all horizontal asymptote. Now equate the highest power of x to be equal to 0. So here we have x term, x square term, right? So that means x square is your highest coefficient, and that coefficient is minus 1 and it is equal to 0. So 1 is equal to 0. So this is not possible. So that means this equation has no horizontal asymptote. This equation has no horizontal asymptote, right? This equation has no horizontal asymptote. Now we will find all oblique asymptote. Right? So what is our function f of x comma y? It is 2x plus 3 times y minus x minus 1 whole square. So we have 2xy plus 3y minus x square minus plus 2x minus 1, right? Minus x square plus 2x minus 1. So this is our phi of x comma y. It is of degree 2, right? It is of degree 2. Highest degree is 2 because this degree is 2, this degree is 1, this degree is 2, this degree is 1, and this is degree 0, constant term. Now we need to collect what? Degree n minus 1, degree n minus 2, and so on. So we will find phi 2 of x comma y. So you collect all degree 2 term. So 2xy minus x square. These two are degree 2 term. Now you collect all degree 1 term, phi1 of x comma y, so which is 3y plus 2x, and then you collect constant term. The constant term is what? is nothing but minus 1. Now what is next step after collecting Pn minus 1, Pn minus 2? Put x is equal to 1, y is equal to m. Put x is equal to 1, y is equal to m. Then this P2 will be converted to a function of m. So P2 of m is 2m minus 1, right? X is 1, y is m. And then P1 of m, so P1 of m is Pm plus 2, and then constant term is minus 1, right? Now to find m, what we need to do? Equate P2 of m to be equal to 0. So we should always equate Pn of m to be equal to 0, right? So that means 2m minus 1 is 0. So in that case, 2m is 1 by 2. So m is 1 by 2. So there is only 1 m, right? There is only 1 m. There is only 1 m. This equation has. Now for this m, you find the corresponding c, right? And for this m, you find the corresponding c. Now to find c, remember there is only 1 m, and this m is to find c for m is equal to 1 by 2. So it has only distinct root, right? There is only 1 m and then 1 m is distinct. Now to find c, the c is given by minus Pn minus 1 of m by Pn dash of m. So minus Pn minus 1 of m divided by Pn dash of m. And we know n is 2 here, right? We know n is 2 here because degree is n. Here degree is n, and we know f of x comma y is degree 2. So in this case, this will be minus P1 of m. So here n is 2 divided by P2 dash of m. And for m is equal to 1 by 2 only we are checking, right? Now what is minus P1 of m? So what is P1 of m? P1 of m is Pm plus 2 divided by P2 dash of m. So P2 dash of m is you differentiate P2 dash. So it is 2, right? Now you put m is equal to 1 by 2. So minus 3 times 1 by 2 plus 2 divided by 2. This will be what? 3 plus 4 minus 7 by 4, right? Minus 7 by only minus 7 by 4 we are getting, right? So if m is 1 by 2, m is 1 by 2, this will be 3 by 2, 3 plus 4, 7 by 2. So it is minus 7 by 4. So for this m, the corresponding c is minus 7 by 4. So the oblique asymptote is given by y is equal to mx plus c. So that's it. So this equation has two asymptote, one oblique asymptote, which is that equation is given by y is equal to x by 2 minus 7 by 4, and it has one vertical asymptote, which is x is equal to minus 3 by 2. Is it clear, everyone? Very simple, very very easy. Now vertical asymptote equate is power of y to 0, and horizontal asymptote equate is power of x to be equal to 0, and for oblique asymptote, for the function of degree n, you form nth degree terms, n minus 1th degree term, and so on. You collect. In that you put x is equal to 1 and y is equal to m. You will get P2, P1, P0. To equate highest degree term to equal to 0, you find m. And for that m, you have to find the corresponding c. If this m is distinct, you have to use the formula. C formula is this. And if this m is equal, you have to use this formula. Right? So we'll move on to our next problem. Find all asymptotes find all asymptotes find all asymptotes to the curve y cube minus 3xy square minus x square y plus 3x cube minus 3x square plus 10xy minus 3y square minus 10x minus 10y plus 7 equal to 0. So we need to find all asymptotes. We need to find all asymptotes to this curve y cube minus 3x y square for this curve, right? So I think my voice is clear, right? Okay. So we need to find all asymptotes to the curve y cube minus 3xy square minus x square y plus 3x cube minus 3xy square and so on, right? Yes. So first what we'll do is we will find all vertical asymptotes and then we will find all horizontal asymptotes. So first we will find all vertical asymptotes. Now for vertical asymptote you have to equate is power of y to 0. Equate highest power of y be equal to 0. Now what is the highest power of y? Here we have y cube and then we have y square. There is only one y cube term, y square term. So equate that to 0. That means it has no vertical asymptotes, right? So it has no vertical asymptotes. Now we will find you find all horizontal asymptotes. Now equate highest power of x to be equal to 0. And what is the highest power of x? It is 3 x cube. There is only one term, right? X cube term. Yes. Again we have 3 is equal to 0. So again there is no vertical and horizontal asymptotes, right? So this equation has no vertical asymptote as well as no horizontal asymptote. Now we will find all oblique asymptotes, right? Now we will find all oblique asymptotes for this curve. Okay. Now to find all oblique asymptotes, now we will find all oblique asymptotes. Now we will find all oblique asymptotes. So we have it is of degree 3 and it is given nicely, right? These are degree 3 terms. The first 4 terms are degree 3 terms, and these 3 are degree 2 term. This is degree 1 term. It is constant term. Already it is grouped in the question itself. So we will form P3 of x comma y. So degree 3 terms y cube minus 3x y square minus x square y plus 3x cube, and then we will form degree 2 terms P2 of x comma y. So minus 3x square plus 10xy minus 3y square, and then degree 1 term P1 of x comma y minus 10x minus 10y, and then all constant term which is 7. Now what we need to put x is equal to 1, y is equal to m, then this will become a function of m. So we have P3 of m. P3 of m is m cube minus 3m square minus m plus 3, and then P2 of m. So P2 of m is minus 3 plus 10m minus 3m square, right? We have to put y is equal to m, x is equal to 1, and then P1 of m will be minus 10 minus 10m, and then P0 of m is 7. Now to find m, we need to equate highest term to equal to 0. Now to find m, we need to equate P3 of m to be equal to 0. In that case, you will have 3 m's, right? But I don't know whether all are distinct or not. So that means we need to find the roots of m cube minus 3m square minus m plus 3 is equal to 0. 1 is the root, right? You know how to solve cubic equations, right? You know how to solve cubic equations. You can see m is equal to 1 is a root, right? You can see m is equal to 1 is a root because if you put m is equal to 1, 1 minus 3 is minus 2 plus 2 is 0. Now find other two roots by synthetic division. This is 1 minus 3 minus 1 and 3. So 1 is a root. So I'm assuming that everyone knows 9th, 10th max, right? So 1 plus 0 is 1. 1 into 1 is 1. Minus 3 plus 1 is minus 2. And this is minus 2. This is minus 3. This is 3. And this is 0. The other two roots are given by m square minus 2m minus 3 is equal to 0. You already did this as quadratic equation. So this m is given by minus b plus or minus root of b square minus 4ac divided by 2 times a. So 2 plus or minus root of 16 by 2. So 2 plus or minus 4 by 2. So 6 by 2 is 3 minus 2 by 2 is minus 1, right? And we see that there are three values of m, right? And we see that all three are distinct also. So for every m, we need to find c. Now to find c, Rahul, I think you joined late. I already explained everything in the beginning, right? You just watch the recordings, or else you just go to YouTube. Live stream is going on. You just backward the video, you'll be getting all the idea. Now to find m, now to find c for m is equal to 1. So for m is equal to 1, we will find c, and then for m is equal to 3, we will find c, and for m is equal to minus 1, we will find c. Now the c value is given by minus pn minus 1 of m divided by pn dash of m. So n is 3 here. So minus p2 of m divided by p3 dash of m. So minus, what is p2 of m? p2 of m is minus 3 plus 10m minus 3m square divided by p3 dash of m. So p3 dash of m, 3m square minus 6m minus 1. Now we are finding c for m is equal to 1. So you put m is equal to 1. Will be 10 minus 6 is 4. 3 minus 6 minus 3. This is minus 4. And c is equal to 1, right? So for m is equal to 1, sorry, for m is equal to 1, c is equal to 1. So that means your first oblique asymptote is y is equal to mx plus c. So x plus 1. So y is equal to x plus 1 is your first oblique asymptote, this curves, right? Y is equal to x plus 1 is the first oblique asymptote, this curves. And to find c for m is equal to 3. So c is given by same formula, minus pn minus 1 of m divided by pn dash of m. So it is minus p2 of m divided by p3 dash of m. Minus p2 of m is minus 3 plus 10m minus 3m square divided by p3 dash of m. 3m square minus 6m minus 1. So here for m is equal to 3 we are doing. So minus 3 plus 30, m is 3 means this will be 9, this will be 27 divided by 3 into 9, 6 into 3 minus 1. So this will become 30 minus 30, this will become 0, right? As 30 minus 30 is 0. So your second oblique asymptote is y is equal to mx plus c. So this is your second oblique asymptote, this curves, right? This is a line, right? This line will be an asymptote to the curve. Now to find c, for m is equal to minus 1, c is given by minus P2 of m by P3 dash of m. So minus P2 of m is minus 3 plus 10m minus 3m square divided by 3m square minus 6m minus 1. For m is equal to minus 1, this will be minus 15 by 8. So 2. So the third oblique asymptote is y is equal to mx plus c. So minus x plus 2. So this has three asymptotes, right? And no vertical asymptote, no horizontal asymptote. But we have three oblique asymptotes. The asymptotes are given by y is equal to x plus 1 is first asymptote, y is equal to 3x is second, and y is equal to minus x plus 2 is your third asymptote, right? So we'll move on to next problem. Problem 3, find all asymptotes for the curve x cube minus 5x square y plus 8xy square minus 4y cube plus x square minus 3xy plus 2y square minus 1 is equal to 0. Directly we will find oblique asymptotes, right? Because highest degree of x is 1 and 1 is equal to 0, not possible. Highest degree of y is minus 4, minus y cube coefficient is minus 4, that is equal to 0 means not possible. Again, there is no vertical asymptotes and horizontal asymptotes. Directly we will find all oblique asymptotes. So first we will collect P3 of x comma y, so which is x cube minus 5x square y plus 8xy square minus 4y cube, and then we will form phi2 of x comma y. So phi2 of x comma y is x square minus 3. I'm collecting degree 2 terms, right? P3 means degree 3 terms, all degree 2 terms. This is degree 2 term, right? Plus 2y square, and there is no degree 1 term, right? There is no degree 1 term, and there is a constant term which is minus 1. Now here we need to put x is equal to 1, y is equal to m. Then we will get phi3 of m to be equal to 1 minus 5m plus 8m square minus 4m cube. Phi2 of m. So phi2 of m is 1 minus 3m plus 2m square, and then phi1 of m. So phi1 of m is 0. So and then we have phi naught of m. Phi naught of m is minus 1. Now to find m, we need to equate phi3 of m to be equal to 0. That is, we need to equate highest degree term to 0. Here degree 3 terms we have, right? Degree 3, the highest. So we need to find the roots for 1 minus 5m plus 8m square minus 4m cube is equal to 0. Now we need to find the roots for this equation. Again, 1 is a root, right? Or this can be written as 4m cube minus 8m square plus 5m minus 1 is equal to 0. So clearly m is equal to 1 is a root, right? M is equal to 1 is a root. Now find the other roots by sensory division. So 4 minus 8, 5 minus 1. You have to put 0 here. You add 4 plus 0 is 4. Multiply 1 into 4 is 4. Add minus 4. 1 into minus 4, 5 minus 4 is 1, and this is 1. This is 0. The other two roots are given by solving 4m square minus 4m plus 1 is equal to 0, right? Now this is a quadratic equation. So m is given by minus b plus or minus root of b square minus 4ac divided by 2 times a. So we have 4 plus or minus 0 by 8. So 1 by 2, 1 by 2. So it has equal roots, right? 4 by 8 plus 4 plus 0 by 8, 4 minus 0 by 8. So that means the values of m are 1, 1 by 2, 1 by 2. Now remember, for m is equal to 1, we need to find corresponding c. That c value is given by this formula, which we are doing. But for m is equal to 1 by 2, to find c, we need to use the second formula because 1 by 2, 1 by 2 are equal roots, right? So the roots are equal, we need to use this formula to find c, right? So first, for m is equal to 1, to find c, for m is equal to 1, and this m is equal to 1 is distinct root. We have only one root which is distinct. That c is given by minus p2 of m by p3 dash of m, right? Because it is degree 3, so it is pn minus 1, so 3 minus 1 minus p2 of m by p3 dash of m. So this is given by minus, so what is p2 of m? 1 minus 3m plus 2m square divided by p3 dash of m. So p3 dash of m is minus by plus 16m minus 12m square, right? Now we need to put m is equal to 1 minus 3 plus 2 divided by minus 5 plus 16 minus 12. This is 0, right? Because my numerator is 0. So c is equal to 0. So your first oblique asymptote is y is equal to mx plus c, and your m is 1, c is 0. So y is equal to x is your first oblique asymptote, right? Now to find c, for m is equal to 1 by 2, and we see that m is equal to 1 by 2 is repeated twice, right? It has equal roots if m is repeated twice. So in that case, your c is given by c square by 2 factorial p3 dash of m, right? P3 double dash of m. So p3 double dash, p2 dash, p1 of m, right? N is 3 here. So p3 double dash of m plus c by 1 factorial p2 dash of m plus p1 of m is equal to 0. So c square by 2 factorial, which is 2. Now p3 double dash of m. We already know p3 dash of m. So p3 double dash will be 16 minus 24m plus c p2 dash of m. So p2 dash of m. So p2 is what? So p2 is 1 minus 3m plus 2m square. So minus 3 plus 4m. Minus 3 plus 4m. And p1 of m is 0. Now you put m is equal to 1 by 2. So c square by 2, 16 minus 24 by 2 minus 3 plus 4 by 2 is 0. So c square by 2, this is 12. 16 minus 4 is 12. And this is 0, right? And this is 0. So that means 4c square by 2 is 0. That means c is 0, right? That means c is 0. Or I made some mistake. Any mistake I made? Oh, this is minus 3. So this will be minus 1 equal to 0. So 2c square minus c is 0. So that means c is 0 or c is equal to 1 by 2. So when m is 0, when m is 1 by 2, c takes either 0 or 1 by 2. So the next asymptotes are mx plus c is one asymptote, mx plus c. So we have three asymptotes. This is your first asymptote, this is your second asymptote, and this is your third asymptote. right? So if your m's are equal roots, if m's are equal, then for that equal m's, the corresponding c is given by using this formula. You have to find c. Very simple. And for one m, you will get two c's. Right? Here we are getting two c's. Is it clear? So again, that's the asymptotes. So the roots are 1, 1 by 2, 1 by 2. So 1 is distinct. For that, you find c using this formula. And 1 by 2, 1 by 2 is repeating. For repeated roots, you find c using this formula, right? If m's are equal, that is repeated. If it is repeated means, if it is repeated means you use this. If it is repeated means you use this. Okay, so we'll move on to last problem and then we'll move on to the next topic. I think you can do very simply. These are just analytical problems. Very simply you can do. There is nothing to visualize or conceptual. Just a formula and then substitution. We'll move on to problem number 4. Find all asymptotes. Find all asymptotes to the curve x plus y whole square, x plus 2y plus 2 equal to x plus 9y minus 2. I will find all oblique asymptote. You find vertical and horizontal asymptotes. You just equate highest power of x to be equal to 0. So can I simplify this first? So this is x square plus y square plus 2xy, x plus 2y plus 2 minus x minus 9y plus 2 is equal to 0. So directly I will write phi 3 of x comma y, phi 2 of x comma y, phi 1 of x comma y, and then constant term phi naught of x comma y. So phi 3, when we will get degree 3 term, x square with this will be degree 3, x cube, and this will be degree 3, right? 2 x square y, this degree 2, and then here we have one degree 3 term, which is x into y square, and here we have one degree 3, which is 2y cube, and then what else you will have? Degree 3, and here 2xy into x, so 2x square y, 2x square y, 4xy square, 4xy square, right? All these are degree 3. Degree 2 will be x square, x is degree 3, this degree 3 again. So 2x square will be degree 2, and y square x, 2y cube, and then 2y square, and then here we have x square y, and then we have 4xy. So all these are degree 2. Degree 1 will be, these two are degree 1, and then degree 2. Right? Now we need to put x is equal to 1 and y is equal to m. So you will be getting p3 of m, p2 of m, p1 of m, and then p naught of m. What is p3 of m? X plus 2m plus m square plus 2m cube plus 2m, x is 1, y is m, 4m square, right? Now phi 2 of m will be 2 plus 2m square plus 4m. This is minus 1 minus 9m and this is 2. Now we need to equate P3 of m to be equal to 0. P3 of m to be equal to 0. So P3 of m. So you collect like terms. 2m cube plus 5m square plus 4m. 2m cube plus 4m plus 5m square plus 1 is equal to 0. Right? Minus 1 is a root, right? You put minus 1, this will be minus 2 plus 5 minus 4 plus 1. So this is 3, this is minus 3. So obviously minus 1 is a root, right? So one root you have to find by trial and error method, synthetic division. So maximum 1 or minus 1 or 2 or minus 2 will be a root. So minus 1 is a one root. So 2, 5, 4, 1, 0, minus 2, 3, 1. The other two roots are given by 2m square plus 3m plus 1 is equal to 0. So m is minus b plus or minus root of b square minus 4ac divided by 2 times a. So minus 3 plus or minus 1 by 4. So minus 3 plus 1 by 4 minus 3 minus 1 by 4 minus 1 and minus 1 by 2. So the values of m are minus 1 by 2 minus 1 minus 1. For m is equal to minus 1 by 2, c can be found using the first formula, and for m is equal to minus 1, we have to find c using the second formula because minus 1 is equal roots, right? Now to find c for m is equal to minus 1 by 2, then c is given by minus p2 of m by p3 dash of m. So minus p2 of m. So p2 of m is 2 plus 2m square plus 4m. P3 dash of m. This is P3 of m. P3 dash of m is 6m square plus 10m plus 4, right? Now we have to put m is equal to minus 1 by 2. So if m is minus 1 by 2, this will be 1 by minus 1 by 2, 1 by 4. So 2 by 4 is 1 by 2. And this is minus 4 times 1 by 2 divided by the m square plus 10m plus 4. So this 2 and this 2 will get cancelled. So you will have 1 by 2 here, and this will be 6 by 4, and this is minus 5. Minus 5 plus 4 is minus 1. So minus 1 by 2 divided by 6 minus 4 by 4, 2 by 4. So again this is 1 by 2. So minus 1 will be your C, right? So your first oblique asymptote is y is equal to mx plus c. So this is your first oblique asymptote, this curve is, right? This is your first oblique asymptote, this curve is. Now to find c, for m is equal to minus 1. So minus 1 is a repeated root, right? So that is given by c square by 2 factorial p3 double dash of m plus c by 1 factorial p2 dash of m plus p1 of m is equal to 0, right? p3 double dash p2 dash p1 of m. Now c square by 2 factorial p3 double dash of m. We already know p3 dash of m. So p3 double dash of m will be 12m plus 10 plus c into p2 dash of m. So p2 of m is this, p2 dash of m will be 4m plus 4. 4m plus 4 and p1 of m. So p1 of m is minus 1 minus 9m to be equal to 0. And we know m is minus 1. So if m is minus 1, this will be minus 2. and if m is minus 1, this will be 0, and if m is minus 1, it will be 8. So minus c square plus 8 is 0. So c square is 8. So c is plus or minus 2 root 2, right? Root of 8. So that means the other oblique asymptotes are y is equal to mx plus c. C can be plus 2 root 2 or mx plus c. So this is the second asymptote, this is the third asymptote, and this is the first asymptote. So again, this equation has three asymptotes, and the three asymptotes are given by these three equations. Is it clear? Can I move on to the next topic? So in the WhatsApp group, I will send you a lot of exercise problem to find all asymptotes. Very simple. You just collect phi 3, maximum 90% it will be degree 3 only. So phi 3, phi 2, phi 1, phi naught. You equate phi 3 of m to be equal to 0. You will be getting roots for m, and for each m you need to find c. If that m is distinct, find c using minus phi 2 of m by phi 3 dash of m. If that m is repeated root, for that m you find c using this, right? Okay, so we'll move on to the next topic, so which is curve based. Yes.
So what if all the three
um all three equal roots, that will not happen, right, for a cubic equation.
x plus x minus
uh, x,
2
x minus 2 whole cube is 0, that means 2 2 2. I will check and tell. And that problem I haven't come across still yet, suddenly you're getting, but good question actually. That I will check, that I will tell, and that I will let you know in the WhatsApp group. The next class I will clarify that. That there is also one formula, but I missed that. Good. Okay, so we'll move on to curve tracing. If they will give one curve, we need to trace that curve, right? We need to form the diagram for that curve. Okay. So with problem, I will explain, right? We will do some 5 6 problems. With the problem, I will explain, right? So there are 5 things we need to look. So I will take one problem and then I will explain. This is PYQ. Rahul. First question is PYQ. I already solved calculus laws of IEBS PYQs. Just I'll send in group. This is the first class you are joining, Madhava, and seen you previously.
the last year also.
Ah, okay. Oh, okay. You changed the name, ah. I thought you didn't come today. Okay, so we'll move on to the first problem. Trace the curve. Trace the curve. Y square into x square minus 1 is equal to 2x minus. Right, we're going to trace the curve. First, what we'll do is we'll put one axis. It will be very interesting. How the graph will be, that is what we are discussing. Raise the comments, we're going to draw the graph of this. So trace the curve y is equal to, see, 5 things we'll be looking, right? 5 things we'll be looking. 6th thing is optional. Thing is optional, but 5 things we need to, 5 things we need to, surely we need to look on. The first is we need to check whether the curve is symmetrical about x-axis and symmetrical about y-axis, right? First thing is symmetry. We need to check whether the curve is symmetrical or not. So A is symmetry. Right? Uh, See, first we will check whether symmetrical about x-axis or not. Symmetrical, symmetrical about x-axis. Symmetrical about x-axis means x-axis act as a mirror. Okay? Symmetrical about x-axis or not. How to check whether symmetrical about x-axis or not, right? To replace y by minus y. If curve remains same, if curve remains same, it is it is symmetrical. It is symmetrical about x-axis, right? If the curve remains same, it is symmetrical about x-axis. So what is the curve here? The curve here is y square into x square minus 1 is equal to 2x minus 1. So you replace y by minus y, it will become same. It will remain same, right? Because minus y whole square is y square. So y square into x square minus 1, 2x minus 1. So it is symmetrical about x-axis. It is symmetrical. It is symmetrical about x-axis. Now we will check whether it is symmetrical about y-axis. Symmetrical about y-axis or not. We will check. Now replace x by the same procedure for all problems, right? We have to write story. So replace x by minus x. If curve remains same, it is symmetrical about y-axis. Now we have what is the curve here? Y square into x square minus 1 is equal to 2x minus 1. To replace x by minus x, the curve will change, right? Because the curve will be y square into x square minus 1 minus 2x minus 1. These two are different, right? They are different. That means it is not symmetrical about, is not symmetrical, is not symmetrical about y-axis, right? It is not symmetrical about y-axis. Is it clear? These two. This curve is symmetrical about x-axis and this curve is not symmetrical about y-axis. Now second, so yes, hello, சொல்லுங்க. இல்ல நம்ம தான் கால் வந்தது எனக்கு. சரி ஓகே. நீங்க தான் பண்ணிருந்தீங்க இந்த நம்பருக்கு. Okay. So I got some 3-4 missed calls from that number. That's why I called. There is an emergency. Okay. So symmetry. So this graph is symmetrical about x-axis and this curve is not symmetrical about y-axis, right? It is symmetrical about, so symmetry is over. Now the second thing is whether we need to find whether this curve is passing through origin or not, right? Whether we need to check whether it is passing through origin or not. If it is passing through origin means you have to find tangent at origin, right? If it is passing through origin means you have to find tangent at origin also. If it is passing through origin, you have to find tangent at origin. You need to check whether it is passing through origin or not. If it is passing through origin, you have to find tangents at origin. But initially we will solve problems such that it is not passing through origin for first two problems. Now when it is passing through origin, if 0, 0 satisfies this equation, it is passing through origin, right? So what is the equation here? Y square into x square minus 1 is equal to 2x minus 1. Now you substitute, hello, சொல்லுங்க பிரசன்னா. ஆமா, ஓகே. இல்ல 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 இல்ல, ஏன்னா நம்ம வெளியே இருக்கேன், நான் உங்களுக்கு அப்புறம் பண்றேன், கிளாஸ்ல இருக்கேன். ஆமா ஆமா ஆமா, நான் அப்புறம் பண்றேன் உங்களுக்கு. You substitute 0, 0. You substitute 0, 0. If it is satisfying the equation, it is passing through origin. If not, it is not passing through origin. So this will be 0 into 0 minus 1, 2 into 0 minus 1. So 0 is equal to minus 1. It is not passing through origin, right? Because 0, 0 is not passing through origin. So the curve is not passing through origin. So as of now, what we inferred is it is not passing through origin and it is symmetrical about x-axis, right? So these two are very mandatory procedure for every problem. Now third is we need to check whether we need to find intercepts, right? We need to find intercepts. So to find intercepts are nothing but x-intercept and y-intercept. Where the curve intercept x-axis is your x-intercept, where the curve intersect y-axis is your y-intercept, right? So for x-intercept, you put x is equal to 0, you find y, right? For x-intercept, for x-intercept, you put y is equal to 0. So for intercepts, you put x is equal to 0 and solve for intercepts, you put x is equal to 0 and solve for y, and you put y is equal to 0, you solve for x, right? So the equation is y square into x square minus 1 equal to 2x minus 1. So when x is 0, you find y. What will be y? Y into 0 minus 1. X is 0. So y is plus or minus 1. So 0, 1 and 0, minus 1 is your y-intercepts, right? Your y-intercepts. So 0, 1 and 0, minus 1. This is your y-axis, this is your x-axis. So this is 0, 1 and this is 0, minus 1. Now to find x-intercept, you put y is equal to 0. So if y is 0, then you will have what? If y is 0, so 0 into x square minus 1 equal to 2x minus 1. So 2x minus 1 is 0. So x is 1 by 2. So 1 by 2 comma 0 is your other intercepts. So 1 by 2 comma 0 is other intercept. The curve is not passing through origin, but the curve is passing through these 3 points, right? Now we will find all asymptotes. We need to find all asymptotes. We need to find all asymptotes. So first what we will do is we will find all asymptotes parallel to x-axis, and then we will find asymptotes parallel to y-axis, and then you find oblique asymptotes. There won't be any oblique asymptotes for this curve. You can check it out, right? Um, so you will not get m. You will not get m. First, asymptotes parallel to x-axis. So asymptote parallel to x-axis. You put x is equal to 0, right? So asymptotes parallel to x-axis. Sorry, equate highest power of x to be equal to 0. So what is the highest power of x here? So here the equation is x square y square minus y square is equal to 2x minus. So uh, highest power of x is x square, right? So equate highest power of x to be equal to 0. So we have y square is 0. So that means y is 0. As this is an asymptote parallel to y axis. Now you find all asymptotes parallel to y axis. Equate highest power of y to be equal to 0. Equate highest power of x to be equal to 0. Coefficient will equate to 0. Coefficient only. So y square is your highest power. So we have x square minus 1 is 0. So x is plus or minus 1. So it has horizontal asymptote. It has horizontal asymptote at y is equal to 0, and it has two vertical asymptotes, which are x is equal to 1 and x is equal to minus 1, right? So that means y is equal to 0 is an horizontal asymptote to the curve. Y is equal to 0 is horizontal asymptote to the curve. And then we have two vertical asymptotes which are at 1 and minus 1. This x is equal to 1 and this x is equal to minus 1, right? This is origin. It's not passing through origin. The curve is intersecting the curve is touching these 3 points, and it has these two asymptotes, right? So we finished 4. Now we will check domain analysis, right? We need to see where the function is defined. Domain analysis. We need to find the domain of the function. So domain is nothing but we need to find all the points where your f of x is defined, or where your f of x comma y is defined, right? Or they will say region of existence, right? Region of existence or domain analysis. Region of existence, where your function is defined, right? So what is our function actually? So it is y square into x square minus 1 is 2x minus 1. So we have y is equal to root of 2x minus 1 by x square minus 1. Very listen carefully. This is a square root function, right? It is a square root function. So how to find domain for square root function? These are 12th and 11th maths. You would have come across baby curve method in your school days. You have prepared for JE. So root function is defined. Root function is defined when this quantity is greater than or equal to 0, right? Root function is defined when this quantity is greater than or equal to 0. So we need to find all x. We need to find all x such that 2x minus 1 divided by x square minus 1 is greater than or equal to 0. Then only root is defined, right? Root of negative is not defined. We are in real numbers only. So we need to find, you should not bring this term here. You should not do that, right? Because this has a 0. It has a 0. If this term has no 0 means you can bring this term here. You should not bring x square minus 1. You should not multiply this with here. This is an inequality. If it is equality, you can do. If it is inequality, you should not do, right? If it is inequality, you should not do. As no 0 means okay. Now, how to find all x that satisfies this equation? This can be done by wavy curve method. So what wavy curve method says is, if you want to solve inequality, you find the roots of numerator, you find the roots of denominator. So what is the roots of numerator? It is 1 by 2. And what is the root of denominator? Plus 1 and minus 1. Now you take any arbitrary point in this interval, you substitute here. If this number is positive, it is positive throughout the interval. That's what wavy curve says. If you want to solve inequality, you should not push this x square minus 1 that side, right? You have to apply wavy curve to find all x. Now you take x equal to 2. You can take any. If x is 2, this will be 2 into 2 is 4. 4 minus 1 is 3. 4 minus 1 is 3. So this is positive. So this interval fully function is positive. Now you take any number between 1 by 2 to 1. For example, let us take 1 by 2, right? Let us take 0.8. So 2 into 0.8. So 2 into 0.8 is 1.6. So 1.6 minus 1 is 0.6, which is positive. 0.8 square minus 1 is negative. Positive by negative is negative. So in this interval, this value will be negative, right? Now in this interval, you take 0, it is positive. You take any x in this interval, you substitute here. If that number is positive, it is positive throughout the interval. If that number is negative, it is negative throughout the interval. Now you take any number here, let us say minus 2. If I take minus 2, 2 into minus 2, minus 4 minus 1 is negative, this is positive. Positive and negative is negative. Now you can see that this function is defined only this region and in this region, because this thing is positive or equal to 0 whenever x belongs to in this interval only. So your domain of your function is at minus 1 and plus 1 it will be infinity, at 1 by 2 it is equal to 0. So your domain will be minus 1 to 1 by 2 union 1 to infinity. So your function is defined from minus 1 to 1 by 2. So minus 1 to 1 by 2, here your function is defined. Here the function is not defined, right? So minus 1 to 1 by 2, here the function is defined, and from 1 to infinity, good, and from 1 to infinity the function is defined. So we can draw graph only in this region. In this region and in this region, your function is not defined, right? Why? Because your under root will be negative in that x. Now we are ready to draw the graph. Now you can see that here we have asymptote, and it is passing through this point, this point, this point, and here we have again asymptote. Now the curve will be right. This is an asymptote. Right. This is an asymptote, and here the function is not defined. And here you can see again we have asymptote. The function is defined here, and then we have a asymptote here. You have asymptote here also, right? You have asymptote here also. That means curve will be this is what the curve. Symmetrical about x-axis. This graph I'm just drawing in this part because it is symmetrical about x-axis, right? That's what I'm drawing like this. And here also function will be decreasing. If you want, you can check for monotonicity also, but that is not required. Is it clear? Can we move on to the next problem? So symmetrical about x-axis, y-axis, origin. If it is passing through origin, there will be a tangent at origins, but here it is not passing through origin. If it is passing through origin, you have to find tangent at origins also, and intercepts, and then asymptote parallel to x-axis, parallel to y-axis, and then domain analysis you have to do where the function is defined. Move on to the next problem. We'll do many problems. You will have more clarity. So trace the curve. Trace the curve y square x square is equal to x square minus a square. So first I'll write fast so you have some idea now. So we'll check for symmetry. First we'll check whether it is symmetrical about x-axis. For that you have to replace y by minus y. What is our function? Y square x square is equal to x square minus a square. If you replace minus y, curve remains same. Curve remains same, and also it is symmetrical about y-axis also. It is symmetrical about y-axis also. If you replace x by minus x, again the curve remains same. That means the curve is symmetrical about x-axis as well as y-axis. The curve is symmetrical about x-axis and y-axis also. Right? Now we'll check whether it is passing through origin or not. The equation is y square x square is equal to x square minus a square. Now you substitute 0 comma 0. So we have 0 is equal to minus a square. If a is 0, it will pass through origin. If a is not 0, it will not pass through origin. Right? Depending upon the value of a, it will pass or not pass. We'll assume that a is not equal to 0. Right? If a is equal to 0, then this question is nothing but what will happen? Y square is equal to 0. Nothing to trace the curve. Actually, in the question, we have to mention that a should not be equal to 0. A is equal to 0, then you will have y square is equal to 0. That means y is equal to 0, which is nothing but your x-axis, right? So it will. So let us assume that this a is not equal to 0. So it will not. It will not pass through origin. It will not pass through origin. The curve is not passing through origin. Now we will find intercepts. You put x equal to 0. So that means your y square into 0 equal to what are you doing? You are putting x equal to 0, right? You are not getting y, right? You are not getting y. No y. If y is equal to 0, x square minus a square is 0. That means x is plus or minus a. So there is no y intercepts, but you have x intercepts. So a comma 0 and minus a comma 0. These are the intercepts. That means the curve is passing through a comma 0 and also it is passing through minus a comma 0. We have x intercepts, right? A comma 0 and minus a comma 0. Now we will find all asymptotes. We will find all asymptotes. So asymptotes parallel to x-axis, or asymptotes parallel to x-axis equate coefficient of highest power of x to be equal to 0. What is highest power of x? Y square minus 1, right? What is the equation here? Y square x square minus a square is 0. Yes, power is so y is plus or minus 1. That means y is plus or minus 1. So y is equal to 1 and y is equal to minus 1 are your horizontal asymptotes. Asymptotes parallel to y axis equate the coefficient of highest power of y to be equal to 0. Highest power of y is x square, x is 0. I'll just check this once. Yes, correct. So here vertical asymptotes are x is equal to 0 and horizontal asymptotes are y is equal to 1 and y is equal to minus 1, right? X is 0, y 1 and minus 1. So y is equal to 1. So let us this is your first asymptote. And we have also another asymptote which is y is equal to minus 1. Y is equal to minus 1. And then we have one vertical asymptote also, which is at x is equal to 0. X is equal to 0, y, then outside noise coming. Someone shouting outside. Then outside noise coming. Okay, so we have two horizontal asymptotes which are 1 and minus 1, and then we have one vertical asymptote which is at x is equal to 0. Now we will do domain analysis. So we have, what is our function actually? Y square is equal to x square minus a square divided by x square, right? So that means y is equal to root of x square minus a square by x square. So we need to do domain analysis. So we need to find all x such that x square minus a square by x square is greater than or equal to 0. Now again you apply wavy curve. Numerator zeros are plus or minus a. Denominator 0 is 0. Right? A and minus a. Now you take any number after this. So if you take a plus 1, so a plus 1 whole square minus a square, this will be positive. This is positive, negative, positive, negative. And you can see that your function is defined. your function is defined in the interval minus a. At minus a and plus a, output will be equal to 0. At 0, the function is undefined. So minus a to 0 union a to infinity. This is where a function is defined, right? Is it correct or not? So x square minus a square. So if you put a plus 1, just a minute. If you put a plus 1, then a plus 1 whole square minus a square is positive. A square is positive. Here, if you put minus 2, a minus by 2 square, or else I will do like, see, this is always positive, right? I will do like, because we don't know what is a, right? This a can be decimal also, a can be fractional, anything. So what I will do is, x, this implies x square minus a square is greater than 0, because this is always positive. For any x, this is positive. So we need to find such that this is positive or 0. So this is a quadratic equation, right? Quadratic equation is greater than 0. So the roots are minus a and plus a, and you see that the outputs are equal to 0 or positive in the interval minus infinity to minus a and a to infinity. So in this region, output is positive because out graph is above the x-axis, and in this region also output is above the x-axis. In this region, your output is below the x-axis. So that means this will be greater than or equal to 0 if x belongs to minus infinity to minus a union a to infinity. So that means the graph is defined from minus infinity to minus a. So here the function is defined minus infinity to minus a, and from a to infinity also the function is defined, right? And the curve has to pass through this point. The function is defined to the right of this and to the left of this, and we have asymptote here. That means the curve has to go like this, and this means the curve has to go like this, and it is symmetrical about x-axis as well as y-axis. So this image will come here, and this image will come here, right? So this is a tracing the curve. Y square x square is equal to x square minus a square. Now we will do the third one. Third problem. Is it clear? Want to third sum? See, we need to find all x such that this is greater than or equal to 0, right? We need to find for what x this thing is greater than or equal to 0. This is always greater than 0 for any x because this is x square. So the whole thing depends upon the numerator. If numerator is greater than or equal to 0, then whole will be greater than or equal to 0. If the numerator is less than 0, whole will be less than 0 because denominator is always positive. So that means x square minus a square is greater than or equal to 0. So we need to find for what x? We need to find for what x your x square minus a square is greater than or equal to 0. This is a quadratic equation, right? This is a quadratic equation, x square minus a square, and the roots are given by minus a and plus a. Minus a and plus a are the roots for x square minus a square. And you see that here the outputs are positive because you can see the graph is above the x-axis. And from in this region, your outputs are below the x-axis. That means your output will be negative. And from a to infinity, again the outputs are positive. So for what x, the output is greater than or equal to 0. Minus infinity to minus a, your outputs are greater than 0. And from a to infinity, again the outputs are greater than 0. So whenever your x belongs to minus infinity to minus a union a to infinity, x square minus a square output will be greater than or equal to 0. Is it clear?
Okay.
So third problem, trace the curve xy square is equal to 4a square into 2a minus x. Or I will do this problem. Trace the curve y square into 2a minus x equal to x. Okay, so we'll trace this curve. So for symmetrical about x-axis, you have to replace y is equal to minus y. What is our curve? Y square into 2a minus x is x cube. So if you replace y by minus y, the curve will remain same. So it is symmetrical about x-axis. If you replace x by minus x, the curve will be different, right? Because this will become plus, this will become minus. So it is symmetrical about x-axis. It is symmetrical about x-axis. So the curve is symmetrical about x-axis. Now we'll check. Now we'll see whether it is passing through origin. First two problem is not passing through origin or no. First two problem is not passing through origin. If it is passing through origin, we have to find a tangent at origin. Now we will see whether it is passing through origin. It will pass through origin, right? We have y square into 2a minus x is equal to x cube. To substitute 0 comma 0, so we have 0 is equal to 0. So it passes through origin. If it is passing through origin, you have to find tangents at origin. Right? Very important. If it is passing through origin, you have to find tangent at origin. So for tangent at origin, you have to equate the coefficient of least degree term. Equate the coefficient of least degree term to be equal to 0. So what is the least degree term here? So 2ay square minus xy square minus x cube. So this is degree 3. This is degree 3 again. And this is degree 2. Right? So degree 2. So degree 2 is 2a, equate the least degree term. Not coefficient, all the term. Equate the least degree term to be equal to 0. Least degree term equal to 0, not equate. You put least degree term. Don't equate. You don't equate the coefficient. Least degree term is equal to 0. So least degree term is 2a y square is equal to 0. So that means y is equal to 0. So at y is equal to 0, it has a tangent. Right? It has a tangent at y is equal to 0. It has a tangent at y is equal to 0. For asymptotes parallel to x-axis, equate the is power of x to 0, equate the is power of y to 0. Whenever I say equate, equate the coefficient. But for tangent at origin, least degree term is equal to 0. right? Now intercepts. So when x is 0, what will be y? 2a minus 0 y square is equal to 0. That means y is 0. When y is 0, your x will be when y is 0. Any mistake I have made? Not only, right? X is also 0. So 0 comma 0 is the only intercept, right? And we know it is passing through origin also. So it has to pass through, it is passing through this origin, right? So it is passing through origin. Now we will find all asymptotes. So we will find asymptotes parallel to x-axis. So equate the coefficient of highest power of x to be equal to 0. So highest power of x is 1 asymptotes parallel to, so no asymptote parallel to x-axis, right? So we have 1 is equal to 0. Highest power of x is x cube. So we have minus 1 is equal to 0. So it is not possible. So there is no asymptotes parallel to x-axis. So asymptotes parallel to y-axis. Equate the coefficient of highest power of y to be equal to 0. So highest power of x is y square. So 2a minus x is 0. 2a minus x is 0, right? Because y square is your highest term. So 2a minus x is the coefficient. So that means x is equal to 2a. So at x is equal to 2a, it has an asymptote parallel to y-axis. That means it is a vertical asymptote. So we have a vertical asymptote at x is equal to 2a. So it is passing through origin also. So we will do domain analysis. So the function is y square 2a minus x equal to x cube. That means y is equal to root of x cube by 2a minus x, and this is defined when whole thing is greater than or equal to 0. That is for what x, so for what x cube divided by 2a minus x is greater than or equal to 0, we need to check. So 0 minus infinity, and this is 2a. Numerator 0 is 0, denominator 0 is 2a. Now this depends upon a also. Actually in the question they have to tell whether your A is positive or A is negative, like that they have to say, but not saying. Okay. So if it is greater than 2A, let us assume A is positive. Let's assume A is positive. If it is greater than 2A and A is positive, right? Let us assume A is positive. If A is positive and if it is greater than 2A, denominator will be negative. And this will be positive because 2A, A is positive. This is a positive number. So 2A minus a number that is greater than 2A. This thing will be negative. This thing will be positive. And this will be positive, it will be negative, right? Because if it is here, this will be negative. So 2A minus this number is always positive. And this number will always negative because here your x is negative. So x cube will also be negative. So that means this thing will be greater than or equal to 0 only in this region. At 0 it is equal to 0 and 2A it is equal to 0. So my domain of f is 0 to 2A. The function is defined only in the interval 0 to 2A. I repeat, see, we need to find for what x cube divided by 2A minus x is greater than or equal to 0. So you apply wavy curve, you put numerator zeros, denominator zeros. You put numerator zeros, you put denominator zeros, right? You put numerator zeros, you put denominator 0. If it is greater than 2A, denominator will be negative because 2A minus a bigger number. So negative. This will be positive because A is positive, 2A cube is positive. So positive and negative, negative. So in this region, this fully negative. And here also 0 to minus infinity, if you take any number, so 2A minus this will always be positive because 2A is bigger. So bigger minus smaller. So denominator is positive. But x cube will be negative in this region, right? Because where x is negative, x cube will be negative. So negative by positive, again negative. Here it is positive, right? You take A, 0 to 2A, A will be there. So 2A minus A is A, again A is positive, A cube is positive, so positive by positive, positive. So 0 to 2A is your domain. So the function is defined only in this region, right? And also this is an asymptote, it has to pass through this. So the curve has to go like this, right? And it is symmetrical about x-axis. So it has to go. Right? So this is the tracing the curve y square 2a minus x is equal to x cube. We'll move on to fifth problem. That is not needed actually. Let us put it. When you trace the curve, let us assume a is positive. That much concept and that much clarity that they itself will not they itself will not have. Book itself they have simply mentioned as A. They should give what is A. A is positive or A is negative or A is what that they are to define. Okay, so we'll move on to another two more questions. After that, we will wind off this topic. No, I'm not getting. Can you come again? Not getting. Can you repeat? Ah, yes, but it is very low. Ah, yes. Now you always assume that A is positive and then you proceed the problem. We are tracing the curve only, right? We don't know what is A. So depending upon positive and negative, it will adjust. Not a problem. You assume that A greater than 0 and do the problem. I'm not getting your voice. Uh, Trace the curve y square into a plus x equal to x square into a minus x, right? So we'll do this fast. So we'll check for symmetry. So first we will see whether it is symmetrical about, we'll check whether it is symmetrical about x-axis. For that you have to replace y by minus y, where curve is y square into a plus x is equal to x square into a minus x. Yes, it is symmetrical about x-axis. If you put y is equal to minus y, the curve will not change. Whether it is symmetrical about y-axis, no, right? If you put x equal to minus x, curve changes. So it is not symmetrical about y-axis. So the curve is, it is symmetrical about x-axis. Now we will see whether it is passing through origin. So the curve is y square into a plus x is equal to x square into a minus x. You put 0 comma 0, it will satisfy, right? It passes through origin. If it passes through origin means you have to find tangent at origin. Tangent at origin, least degree term is equal to 0. So here y square ay square plus xy square minus ax square plus x cube is 0. So degree 2 is the least. So ay square minus ax square is 0. That means y square is x square. So that means y is plus or minus x. So that means y is equal to x and y is equal to minus x. Both are tangent at origin. That means the tangent is passing through origin also. So y is equal to x and y is equal to minus x. So y is equal to x we know, and y is equal to minus x is also a tangent at origin. So it is passing through origin as well as this is y is equal to x. You know equation of y is equal to x and y is equal to minus x, right? This y is equal to minus x. You know graph, right? Very elementary. This y is equal to x graph. This y is equal to minus x graph. So these two are tangents at the origin. So we will find intercepts. So you put x equal to 0. So if x is 0, y square into a plus 0 is equal to 0. That means y is 0. So we know already that 0 comma 0 is passing through. When y is 0, what about x square into a plus x? That means x is equal to a, right? That means a minus x is 0. That means x is equal to a. That means it has an intercept at a comma 0. It has intercept at 0 comma 0 and a comma 0. 0 comma 0 we already know. A comma 0. A comma 0. Again I'm assuming a is positive only because I'm marking a to the right of origin. Now we will find all asymptotes. We will see whether it has vertical asymptotes and horizontal asymptotes. The first is asymptotes parallel to x-axis equate highest power of x to be equal to 0. What is highest power of x? There is no asymptotes, right? Because ay square xy square minus ax square plus x cube is equal to 0. Highest power of x is 1 is equal to 0. So this is not possible. So there is no asymptote parallel to x-axis. That means there is no horizontal asymptote, right? There is no horizontal asymptote. Now we will see whether it has asymptote parallel to y-axis. We will see. So equate highest power of y to be equal to 0. See, whenever asymptotes, you have to equate coefficient, right? But in tangent and origin, you have to equate all the term to be equal to 0. Least degree term to be equal to 0. So highest power of y is y square. So that coefficient is x plus a is equal to 0. That means x is equal to minus a. So x is equal to minus a is it has vertical asymptote. It has vertical asymptote at x equal to minus a. We have one more asymptote at x equal to minus a. This x is equal to minus a is another asymptote. Now we will do domain analysis. We will do domain analysis. So what is the function y square into a plus x is equal to x square into a minus x. That means a x square into a minus x by a plus x. So we need to find for what x x square into a minus x divided by a plus x is greater than or equal to 0. So we'll apply wavy curve. So numerator zeros are 0, a and minus a, right? Now we need to check whether it is positive or not. This is always positive, right? This is always positive. So this reduce, we don't need this actually, right? Because this is always positive. So this depends upon a minus x by a plus x is greater than or equal to 0. Now if you take a plus 1, right? If you take x to be a plus 1, a minus a plus 1, that will be negative. This will be positive. Again, this will be negative. This will be positive. So that means your domain of f is open minus a to closed a, because at closed a it is equal to 0. At minus a the function is undefined. I think you are getting domain analysis, right? Very simple actually. Actually, I am finding for what input this thing is greater than or equal to 0. If you take any point to the right of a, let us assume a is positive. Let us take a plus 1. Then a minus a plus 1. A is smaller, a plus 1 is bigger. So a minus a plus 1 will be smaller. Right? Sorry, negative. A minus a plus 1 will be negative. So negative by positive is negative. So the function is defined from minus a to a. So the function is defined only in this region. Function is defined only in the region minus a to plus a, and we have all these asymptotes, right? Now I'll draw the graph. It has to be tangent at these 2 points. This is a tangent, and here also we have one. Sorry, it has to be an asymptote for these two. Your curve has to be an asymptote for these two line and this line. I'll draw. So the curve starts here. It is coming. It is passing through origin, and it has to be a tangent for this also, and it has to be a tangent for this also, right? I'll redraw. I'll redraw. Right? It has to go like this. And see this symmetry also. These two lines are symmetric also. That means this graph again will come here because these two are symmetric, right? It is symmetric about this line and this line also, and it is an origin. It has to pass through this, and these two will reflect. Right? So this is how the graph will be. So I will send you a lot of problems for practice the WhatsApp group. So it will be easy for you. Is it clear? Right? This is how the graph will be. So trace the curve y square into a plus x is equal to x square into a minus. So interesting topic. Very first topic is we have found all the asymptotes, right? Again, these are very simple problems. Find all asymptotes, oblique asymptotes. There is a way to find all oblique asymptotes. And vertical asymptote, horizontal asymptotes, again very easy. And then we have did curve tracing, right? So in the WhatsApp group, I will send you five problems for exercise based on curve tracing and vertical and finding all asymptotes. Is it clear? Is there any doubt? I'm winding off. I'm winding off. Is there any doubt? Okay, so I'll stop here. So next class we will start maxima and minima. Thank you. Bye. Yes. Can you come back to me in Telegram or WhatsApp?